Hey y'all, so here's what we got going on today. We are pretty much at the end of this unit, at the end of light, right? We've talked about pretty much everything that there is that we're going to cover with optics, regarding the ray model of light, regarding mirrors and reflection, regarding refraction through any kind of medium, and then also refraction with lenses to kind of focus that light. And so today what we're going to do is we're going to spend a little bit of time, and I'm going to have you guys choose and watch through and look through some of these videos that just talk about some different applications of these optical principles that we see. It's actually really cool. There's all sorts of different applications that we can have with optics, all sorts of different things that involve optics, phenomena that you see all the time. And if we think of how important vision is and sight to the way that we perceive the world, it does make sense that optics, the study kind of in the science behind how that light moves through and bounces off of surfaces, would be very important to a lot of things that we see, right? And therefore a lot of things that are kind of note to us. So basically you guys are going to choose at least 4 of these videos that I've kind of chosen here. You're going to watch them, and then you're just going to kind of write down something interesting or cool that you learned, and or any other questions that you still have. So pretty straightforward, just kind of like a fun, relaxing thing for you guys to explore that. I did want to go over a couple of cool demonstrations because I do happen to have a few things here. And these are covered in some of these videos, but they're still kind of fun. So one thing is that if you wear glasses like me and you ever like lose them, I learned this from my physics professor in college, and it's kind of crazy. It's really weird to think about. But if you ever lose your glasses, right, and so you can't see anything. So right now it's like I'm pretty blind. Like I can't really make out what is on my screen. If I squint, I can see a little bit better, which is, why does that work? Why does squinting actually help me to kind of focus? But it's really hard still to see and make out what's on my page in front of me. So one thing you can do is you can make a tiny hole with your hand or with your finger, and you can look through that, and then all of a sudden you can see. I can read essentially everything perfectly. So if you ever lose your glasses, that's one thing to do. And my physics professor told me that you can buy a cheap pair of sunglasses, punch out the lenses, and then if you poke a hole, a single hole or multiple holes over it, I did multiple holes so that it gives me kind of a wider area that I can see without just looking at one hole, so I don't have to always kind of like pivot around. But if you poke at those holes, and kind of the finer they are, the less light they let in, but the kind of sharper the vision, and I can see all of a sudden through these holes pretty clearly, right, what's on the page. So that's one kind of cool thing that you guys can do. One of the videos talks about that. Another thing, and I had to share this because I happen to have the sheets here for it, but this is actually a polarizing filter. And what this essentially means, and what these do, is that light, if you remember, it's an electromagnetic wave, so it's an oscillating electric field and a perpendicular oscillating magnetic field. But the thing is it doesn't always those fields don't just oscillate up and down and left and right. They oscillate in all sorts of directions, so they can be kind of side to side at like an angle, up and down, left and right, diagonal, and at all sorts of 360 degrees within there, right? And the angle at which it's kind of oscillating is known as its polarization, right? And so all light, when it's created, it's usually created different waves at once with all sorts of different of those angles that they're at, different polarizations. So this is a polarizing sheet. And what this does is this actually has this little kind of fine line in here that you can see. That tells you which way it's kind of polarizing the light. And so what this does is this only allows, since this one's a horizontal filter, it only allows light waves that are traveling, where the electric fields are traveling horizontally, to pass through. So if I had a vertically traveling wavelength, it wouldn't pass through this, right? So only the horizontal are allowed to pass through this. And what's cool is that if I have this other one and it's in its horizontal position, it's fine. If I kind of angle it, it fades a little bit and gets a little darker and darker and darker. And then there comes a point where when I have it vertical, no light gets through, which is so cool. And what's happening is that if I have this vertical, it's only allowing vertical waves to pass through. And if I have this one horizontal, it's only allowing horizontal waves to pass through. So no waves pass through, right? Whereas if they're an angle, then there's still some fraction of those waves that are actually being allowed to pass through still. It's really cool. So that's polarization of light. It's kind of a cool thing. You'll see this if you've ever had, or if you happen to have polarized glasses. You can see this, and you can actually do this if you have 2 pairs, right? They should be, usually those glasses are polarized vertically, right? The lenses are, which is why, by the way, and the reason for that is off of a lot of flat horizontal surfaces, those tend to polarize the light horizontally. So off of like roads or bodies of water, right, they kind of leave most of the light polarized horizontally. And so if you have a vertical filter, it kind of gets rid of that glare that you get from water and from the road. That's why polarized glasses are good when you're on the water or when you're driving, right? Eliminate some of that glare. But if you take one pair of glasses and put them this way and the other pair and put them that way, you should get the same kind of effect. So some cool things that you end up seeing. More videos on that. There's some cool videos on fiber optic cables, or one video here, which has to do with essentially total internal reflection and how that works and how we actually use this for telecommunications, for internet, for texting, all sorts of things. This is a quick way to move information. It's actually a really, really, really big deal that we have these. This video on cameras, how to film the inside of the microwave, for some reason this keeps coming up as the tag for it, and I don't know why. It's not that. It's actually a different video. It's by my guy Steve Mould, the guy with a British accent, which is quite enjoyable. And this one's actually, I recommend watching this one. In fact, I might even require you guys to watch that one because it really does a good job of summarizing everything that we've learned about with light, waves, and optics so far. Electron microscopes, this one's really cool, talking about how we can look at things that are actually smaller than the wavelength, than visible wavelengths of light, and how we can actually see them still. Telescopes is kind of cool, and if you guys are interested in knowing how we use kind of telescopes and how those work. And this short little one on animal eyes. I don't know if you guys are aware, but like we have round pupils, for example, but things like goats, for example, down the street, the neighbors have some goats, and if you ever look at goat eyes, they're terrifying. Try it. Or even cat eyes, right? They're pupils of different shapes, and why is that? So some different things. Like I said, you guys have to watch at least 4 of them. You could watch all of them. They're really cool. They're really fun. Feel free to kind of mess with the speeds on them, but that's what's going on today. Now, next class, I will be explaining to you guys how a rainbow works. So we're going to address kind of that question that we first asked at the beginning of this quarter, and I'm going to give you guys the full explanation of it from top to bottom. After that, we only have, really after this, we only have a couple of weeks left. There's only like 4 or 5 classes. So you guys can look forward to, we're going to do some special topics in physics. It'll be mostly just kind of fun, like me lecturing, maybe a few videos or links for you guys to check out. Nothing too crazy. Might have you guys do a little bit of research yourselves, maybe make some videos. We'll see what happens, but that's that. Hope you all are doing well, and I will talk to you later.